There, Joshua Johnson here. This is my second video on how to do simple long division problems. So in this video, I'm just going to do a few examples. I started with 1/2 in my previous video. So a different example, but similar. I'll try, we'll say 1/4. So I already know that 1/4 is equal to 0.25 just because I've done these problems before. And so as we work through this procedure of long division, if we arrive at the same answer, we know we've done the procedure right, or we can feel pretty confident that we've done the procedure right. So once we have that confidence in our ability to do the procedure, then we can use this procedure to solve much harder problems. So step one, we know that the numerator in this problem is 1, and the denominator in this problem is 4. So when we put that into a long division format, like in the previous problem, denominator goes on the outside, 4, numerator goes on the inside, which is the 1. A little bit messy here. Let's extend this. So for this procedure, what we do, we put the decimal point in to the right of whatever value is inside the long division symbol, and then we put some zeros. I don't know necessarily how many zeros to put. I just tend to put 2 because through my experience, that's kind of my intuition, like that's a good number to start with. Now we consider how many times does 4 go into 1, which it doesn't because 4 is bigger than 1. So 0 times, 4 goes into 1 0 times. So that 0 value goes above the 1, keeping it nice and vertically aligned. So from here, we multiply. So 0 times 4 is 0, and that goes underneath that vertical column that we were developing. So 0 times 4 is 0. That goes underneath our 1. So then we subtract those two numbers. 1 minus 0 is 0. Now we bring the first 0 down in our next column. It'll be 0. I brought that down vertically, nice and aligned. Now we consider how many times does 4, the whole number 4, go into 10. And I know that 4 goes into 10 2 times. So we recreate our decimal point. So above that 0 that we just brought down, that column, we put in that 2 that I just mentioned. So from here, 2 times 4 is 8, which goes underneath this value that we just dealt with. 2 times 4 is 8. Then again, we subtract. Basically, this long division is just, just a few steps, maybe 3, 4, 5 steps that it just repeats until we get an answer. Again, 10 minus 8 is 2. Now we bring down the next 0, keeping that nice and vertically aligned. I'll indicate here in a different color. Let's use blue. So if you try to keep it, I'll use dotted lines. If you try to notice, I'm trying to keep these columns nice and aligned, so that first 0 we brought down is nice and columnarly aligned. The second 0 I brought down from here, for example, again, they're nice and vertically aligned. We don't want them shifting sideways, otherwise the problem gets a bit messy and it becomes harder to understand and easier to make a mistake. Now again, repeating this process, how many times does 4 go into 20? Well, I know that 4 goes into 25 times because I have a good understanding of my times tables. Times tables are foundational to understanding long division. So above that 0 that I just brought down is that 5. 4 goes into 25 times. So 4 times 5, I know is 20. Goes underneath here. Now we subtract those two. 20 minus 20 is 0. Now there's no value left. We have no remainder. If there was a remainder, we'd keep doing this process. I'd install some more zeros and keep bringing them down and keep figuring multiples, but there's no remainder. So I know that I have arrived at my answer. So I know the solution, the answer I've arrived at is 1/4 equals 0.25, which is the same as what I already knew, what I started with. So based on that matching, those two values matching, those answers matching, I can feel confident that I did this procedure correctly. I'll do another example. There's different kinds of fractions. Not every fraction ends nice and neat, which you'll find as you do some of these. And again, I'm sticking to basically single digit fractions just because this is a bit of an introduction. So I'll try a different fraction, say 1/3. Now this is one of those special fractions that keeps going and going and going, which you'll see in a moment. So I'll set up my long division bracket, denominator on the outside, numerator on the inside, install my decimal point. And I'll try 3 zeros this time. It doesn't really matter how many zeros I put in initially. I'll just try something different. And putting those zeros in is valid because 1 is the same as 1.0, is the same as 1.00. We haven't changed anything numerically speaking, so it's valid to do that. How many times does 3 go into 1? Well, it doesn't. 3 is bigger than 1. So how many times it goes into it? Goes above your first value, the first column we're forming. 0 times 3 is 0, I know. So it goes underneath that first column. Now we subtract. 1 minus 0 is 1. Bring the first 0 down. How many times does 3 go into 10? Well, I know 3 goes into 10 3 times. So that goes above that 0 that we just brought down. 3 times 3, I know, is 9. That goes underneath the 0 that we brought down. 10 minus 9 is 1. And again, maintaining these nice alignment on these columns, bring down my second 0. How many times does 3 go into 10? Well, I know it goes into 10 3 times, as we've just established. Maintaining this alignment again. The first 3 is above the first 0, second 3 is above the second 0. Even the first 0 that you see, 0.33, is above that 1, so keeping things nice and aligned. 3 times 3 is 10, so repeating this process. 10 minus, sorry, I just made a mistake. I'll erase that. See, even the pros make mistakes, so it's all good. I should say 3 times 3 is 9. So 10 minus 9 is 1, bringing another 0 down. So hopefully you're recognizing a pattern here. We just keep getting 3, 3, 3, 3, 3. This is one of those special fractions. So if I kept adding zeros and kept bringing zeros down and doing these multiples, I will just keep getting that same answer. So that will keep going into infinity. So when you have a fraction like this, what you do is just choose a number of place values to extend to. Usually it's 2. Sometimes it's 1, but that's kind of, there's reasons for that. But for now, let's just stick to 2. So based on this pattern, I can say that 1/3 equals 0.33, and it keeps going 3, 3, 3. So I just draw a little dash over one of the 3's, and that represents the decimal form of that fractional value. So again, I'll put a box around my answer and a line. Hopefully that gives you some understanding of long division. So the three examples I've done in these 2 videos. But yeah, hopefully that gives you some basic understanding. Have a good day, and we will see you later.